Okay, I'm going to work on page 2. I have a quadratic graph, and I'm asked about the domain. Now, there are arrows here, so if you wanted to use the blue pieces of paper, you would go like this, and because you're hitting arrows on both sides, that's letting you know it's from negative infinity to infinity. With the range, I come up from the bottom, but I hit arrows, so that's negative infinity, up to this top. Now, it's a little hard to see what the top is, but that's why this is labeled. 3.125 is the highest value of y. So my range is from negative infinity to 3.125. Now I'm using a square bracket here because there's an actual point here at 3.125. All right. Now before I do interval of increase and decrease, I want to label these 2 points because I think they're helpful. So you have to think at the very end of this graph, like if you kept on going down this way, what would this point be? Well, you had to go over and then down. So the over is positive infinity and down is negative infinity. And to get here, back and then down. So back is negative infinity and down is negative infinity. Okay, so those are these ordered pairs, and they're going to help with our interval of increase and decrease. Increase means the uphill part. If this is a roller coaster, you go up and then you go down. So I'm only looking at this side of the graph. And I'm only thinking about the x values. So that's why it's nice to have these labeled. X, this is the x, from negative infinity to, and here's the other x value, 0.25. That's my increasing point. And then for the decrease, this is the downhill part of the roller coaster. It starts at 0.25 and it goes to infinity. We're looking at the x values for intervals of increase and decrease. So it doesn't matter that this y value is negative infinity. It's this that matters. So from 0.25 to infinity. Okay, I can look at my x-intercepts right here. That one's 3/2. That one's already listed, and then -1. If you know these x-intercepts, which are the same thing as solutions, you automatically know the factors. If I know that one of the answers, one of the solutions is -1, I know x plus 1 is the factor. If I know 3/2, I have to think about what's the mini equation that came from. It came from 2x minus 3. That's the mini equation that would give you the answer or the solution 3/2. So those are my factors. And then for end behavior, I'm really looking at these arrows. They're both going down, right? I'm looking at these y values. As x approaches infinity, what's y? It's negative infinity. As x approaches negative infinity, what's y? Negative infinity. Okay. Write the equation of the quadratic function pictured in vertex form. Okay, so I'm going to really focus in on this vertex. I had to go back 2 and down 5. So the back 2 is kind of weird because I need x plus 2 to go to the left 2. And then down 5 minus 5. Make it a y equals. Y-intercept, that's this point right here, is 0, -1. Okay, Maya's using the quadratic formula. And she finds that the discriminant is -20. I think I'm going to go find, do I have a blue paper somewhere on this desk? Maybe. No, hold on. I'm going to pause and come right back. Okay, so here's our flow chart. And if you're using the quadratic formula, this part right here, that's the discriminant, the b squared minus 4ac. That's what we mean when we say the discriminant. If it's a negative number, which in this question it's -20, that means you're going to get 2 imaginary roots. 2 imaginary roots. And the graph, if you saw what the graph looks like for one of these, it probably looks something like this, where the curve never touches the x-axis, right? This is an example of a graph that has no solutions because it doesn't have any x-intercepts. This one has 2 solutions, right? That's what solutions mean. They mean x-intercepts. So when I have a graph that never touches, like that one or this one, those have no solutions, right? Okay. So what does Maya know about the quadratic function? Well, there's no real solutions. There's no real solutions. B, they're imaginary. It has 2 imaginary solutions, but no real solutions. It won't have any x-intercepts. It won't have 2, won't have 1, won't have a double root. It will have no x-intercepts. So the graph has to look something like either this one or this one if it has imaginary solutions. Okay, Max solved the quadratic equation. One of the solutions to the equation was 2 plus I square root 3. Well, think about all of our solutions take this form, 2 plus or minus I square root 3. So if I know that one of them is 2 plus I square root 3, then the other one has to be 2 minus I square root 3. I'm going to write that down because I get confused when I start looking at all these answer choices. They all look so similar. This is the one that I want. Okay, it's D. Okay, solve with the quadratic formula. First, you have to set it equal to 0. If you start at the top of your flow chart, that is always the first step. This is 3x squared minus 4x plus 6. I would highly recommend you take a moment to write down A, B, and C. Move up a little bit. There's A, B, and C. A is 3, B is -4, and C is 6. And now I'm going to be putting these numbers into this equation. Negative B is going to turn this into a positive 4, plus or minus B squared minus 4AC. So that's -4 squared minus 4 times 3 times 6. All over 2A. 2 times 3. I'll just do that. That's 6. Okay, -4 squared is 16. You're going to do this in your calculator, though. Let me go grab one. Okay. Oop, we got to work quick. Oh, batteries are dead. Let's get another one. Okay. So I'm going to be putting this into the calculator just as it is written on this paper. So just what's under the radical here. So I'm going to do -4 squared minus 4 times 3 times 6 and see what the output is. -56. So in my next line, now be careful, you have to know the difference between a negative and a minus for this. -56 is going to replace this because that's the discriminant. Now right now, I know I'm going to get two imaginary solutions because the discriminant's negative, but I'm going to simplify it. So over here, I'll make a birthday cake for 56, 28, 2, 14, 2, 7, 7, 1. That means the square root of -56 would be 2, 2, 2, 7, and -1. Bring out a 2, bring out an I, leave in 14. So I go back here, and I think I need a little more space, and I'll do 4 plus or minus 2I square root 14 over 6. Now I'm not quite done because I can do a little bit more simplifying. Now you can't touch the 14 that's under the radical. That is not a like term. But I can look at the 4, the 2, and the 6, and I see that they're all divisible by 2, so I'll divide each one by 2 because that's my GCF. So I end up with 2 plus or minus I square root 14 over 3. So I'll do 2 plus I square root 14 over 3 and 2 minus I square root 14 over 3. All right, there's page 2.